Hi, everybody. Welcome to instructions for the lab number 6 for October 15th, 2025 in Physics 1320. So I'm going to prepare this video because, well, in all honesty, I'm not feeling well today and we have a lot of ground to cover. So I'm going to prepare this lab and then turn you loose with some video instructions to do the lab on your own and then to write up a report, not formal, but just a what happened kind of lab report on what you have done. So in order to accomplish this, there are many videos that you're going to watch. They're very short, and each one of them isolates a topic. But the topics that we're going to talk about today are inductors, capacitors, and the circuits that you use inductors and capacitors in, plus for each something that is called a time constant. So if you take a look at our Moodle page, you'll see that it says our next lab meeting, 5 and 6, will be held on October 15th, which is today. So what I would like you to do is to watch this video, what is an inductor? Circuits that have inductors, R is for resistor, L is for inductor because I is already being used for current. And an inductor basically stores electricity in a certain way. And an RL circuit, like I said, is a circuit that contains both resistors and inductors. So if you start to get confused at any point, inductors are measured in the units of henries, which are quite large, so generally measured in microhenries or something like that. The next circuit that we need to take a look at is a capacitor. And capacitors are another type of a circuit that stores energy in a different way. So capacitors, to make a long story short, store energy in an electric field, and capacitance is measured in units of farads. Then, like I said, inductors, well, I didn't say, but inductors store electricity in magnetic fields and are measured in units of henries. So basically, if you look at our web page, if you look at our Moodle page, I've printed out a summary here that talks about natural response of each, an RL circuit and an RC circuit. And it also talks about something called a time constant, which you'll be required to calculate. And the calculation, the time constant itself is a characteristic of a particular circuit. So it's an important quantity. So the time constant of an RL circuit, one having inductors in it, is equal to the inductance divided by the resistance. And one of the videos that we have will work it out. That comes out in dimensions of time in units of seconds if you use henries and resistance in ohms. It amounts to, and once again, this is in the videos, but it's a particular percentage of the amount of charge that is either charged or discharged into an inductor over some period of time. And that's the amount of time. And the percent is it's over 60%. So if you look at a bell curve, or it's not really a bell curve, but if you look at the change in inductance when 63% of the charge is being stored, that's called one time constant. Similarly, for an RC circuit, it is the time constant is calculated using a similar process, which turns out to be the resistance of the circuit in ohms times the capacitance of the circuit in farads. And once again, it's over 60%. It's the time required for over 60% of the charge to either charge up or discharge from that circuit. But when you're going through a Moodle page, as you watch these different videos, you'll learn about these properties. So by the time you're done with RL and RC circuits, I want you to understand what components go into each, and then I want you to understand how to calculate the time constant and to recognize that if you use SI base units of farads, ohms, and henries, that the time constant for each will be calculated in seconds. So there's no conversion beyond getting out of microfarads or microhenries or whatever, or milliohms or whatever. When you have those two numbers in those base units, then the response, the time constant will be in seconds. So if you read through this summary on our Moodle page, it will give you the highlights of that particular calculation. Now, the second part that of our lab today is to work with the analog Discovery 3 oscilloscope. And this oscilloscope is much different than the ones that you have used in the past. So the analog Discovery is very simple. It's a teeny little baby, and it plugs directly into your PC. So the analog Discovery 3 oscilloscope is just a little box, and it comes with some accessories. And it basically, as you can see, the gentleman on the workbench, I hope. Let me make sure I've got that correct. Let me check my share. There he is. Okay, when you see the fellow on the workbench here, this is the entire box, and this is the analog Discovery 3 oscilloscope. Now, it really is more than an oscilloscope. It's it's also a wave generator, function generator, and a whole bunch of other things. So the way that this works is you download to a PC, whether it's a laptop, it doesn't matter if it's Mac or Windows, you download a software which is called Waveform. And I'm just going to bring up Waveform on my computer, if it will let me do it, because I have my um, yeah, it's not gonna let me bring it up. It's the waveform software, which they'll talk about in the videos. You download it onto your computer, and then you plug in the uh, the analog Discovery 3 using a C-ring to USB connector to your PC, and then you have all the functions that you have of one of those big clunky CRO cathode ray oscilloscopes that we have in the lab. So the second part of your lab is to watch these videos. Come here, I'll just take a look us here. To read these, watch these videos, beginning here with the Analog 3 Discovery Oscilloscope. And then we've got some videos hands-on with the Digilant, excuse me, I always say that incorrectly. And then there are a total of 5 videos. I think I have video 1, video 2, video 3, video 4, video 5, and then a demo using the waveform generator. So there are a total of 7 videos that I'd like you to watch. Now, as you'll see with the middle 5 videos, they're very short, 8 minutes, 6 minutes, 5 minutes, and so forth. So this is not going to take you very much time. But what I'm going to do is I'm going to leave you with my Analog 3 Discovery oscilloscope, and I want you to load it on. You can use computer equipment in the lab, or you can use one at home. But I want you to work as a group. Since there are only 4 of you, I think you can pull this off without too much trouble. And then I want you to write me a little report, just telling me what you did with the oscilloscope and how it went. So I've left you with a pigtail that plugs in so that you have all the leads, a little breadboard, a couple of other adapters that you're probably not going to need, the USB to C-ring cable, and the Digilant Analog Discovery 3 itself. So watch the videos, go through the exercises, write me a report, and that will take care of our work for labs 5 and 6 on October 15th, 2025. Now, as usual, I will be here almost all of the time to help you. So if you have questions or problems, let me know. But I'm going to get this recording put up on the Moodle page, and then I'm going to go over to the lab and get you guys started, and then I'm going to turn you loose to do this on your own time. Thanks, everybody. Have a great day.